Last lesson in Unit 9 is about multiplying probabilities. So one thing we were talking about in the class yesterday is that in probability we have things backwards. And means we're going to multiply. And we saw that yesterday in independence and dependence. I said that when I test for independence, I see if the probability of A intersect B is the same as the probability of A times the probability of B. Notice intersection means and we do this by multiplying. Or, well, then that means to add in probability. It's backwards in every other branch of math. Or means to multiply in algebra, and means to add in algebra. So we got to keep that straight, and that's just part of learning. All right, so let's just dive right into it. It's not that bad. So we're going to look at this. Don't mind all this wording up here. We're just going to look at this spinner below. We get to spin it twice, and we get to record what we got each time. Are the outcomes of two spins dependent or independent? Well, we've already realized that they are independent. We talked about that yesterday. One spin will not affect the next spin. What is the probability that you will get an even on the first spin and a number greater than 5 on the second spin? So here's that key word again, and. So now our brains have to realize that really we're going to be multiplying our results together. So the first thing we want to look at is the probability of getting an even number. Well, we've got 8 spaces over there, and out of those 8 spaces, 4 are evens. And a number greater than 5. A number greater than 5. So that's my second spin. Again, there are 8 chances, and out of numbers greater than 5, 3. All right, if we multiply this together, I'm going to do some cross cancellation to make my life easier. The probability of those two events happening is 3 out of 16. What's the probability you will spin a prime number and a perfect square in either order? Oh, and either order. Okay. 8 chances. The probability that it's prime. When I come over here and count up, oops, too many parentheses, and I count up prime, we've got 1, 2, 3, 4 prime numbers. And the probability that it's a perfect square. Well, the probability that it's a perfect square is 1, 2. 2 perfect squares. 2 perfect squares out of 8. Once again, I'm going to do a little math right here, and I get 1/8. But that just says if I do a prime first and then a square. It didn't say I had to go in order. It wasn't conditional probability, given that you got a prime first and then you got a perfect square. It said I can win in any order. So I can also win on the probability that I get a square first and then I get a prime. Well, guess what? The basic math doesn't change. The probability of getting a perfect square is there are still 2 out of 8, and the probability of getting a prime number is there are still 4 numbers out of 8 that are prime. So that's still going to get me 1/8. Now, what am I going to do with the 1/8 I had here, the 1/8 I had there? I'm going to add them together because it said I can win this way or this way. So now we're going to go back to that first page, right? Or means I add together, and means I multiplied. Well, here was the and happening right here. I get a prime number and a square. Or I could win with a square and a prime number. So when I add these final things together, 1/8 plus 1/8 is 2/8, or there's a 1/4 chance of these events happening. So that's why it's very important to read carefully. I had to do both and or. All right. So where is this used in the real world? Say a power generating facility has 3 primary safety switches in case of an emergency. So I'm going to come down here and I'm going to put my 3 switches. There they are. The probability that any one of these switches fails is 5%. Now I'm going to come over here and put 0.05 because we always forget to change 5% into a number. 5% is not a number. It's a description. It's a word. It's 5 per 100. What is the probability that all 3 will fail given that the switches are independent of one another? Okay, that means one failing will not make another one fail more greatly. So basically, if I were the foreman of this company, what's the probability that this switch fails and this switch fails and the third switch fails? I'll be very upset if all 3 fail, because then there's going to be no power. Well, 0.05 and means multiply by 0.05 and means multiply by 0.05. If I multiply those all together, well, 5 times 5 is 25. That's 125. And I'm going to move the decimal 1, 2, 3, 4, 5, 6 places. 1, 2, 3, 4, 5, 6. So that is a 0.000125 chance. If I wanted to change that into a percentage, it would be a 0.0125%. That's an incredibly small chance of all 3 failing. All right. And the last problem we're going to look at is a two-way table. So just so we get a little more practice on reading a two-way table. A company was determining the effectiveness of its warranty sales on computers. So a warranty sale. You know, that's when you go in and you buy something and then you get to the cash register and they're like, hey, listen, we'll sell you an extra set of protection because let's say your computer fails in 2 years, you're not under warranty. So it's another way for them to make money. They know that the chances of their product failing after a certain amount of time. So they just always try and sell you an extended warranty because they know your product isn't going to fail then, but they're going to get you for more money. So they took the data on the number of customers who purchased warranties on 2 different brands of computers. If a customer was chosen at random, what's the probability they did not purchase a warranty? Remember, this is those who did purchase a warranty, so we have to keep that in mind. All right, so this is what we're going to look at. So for type 1, 68% of the people purchased type 1, and 35% purchased a warranty. So I'm going to stop right here, and I'm going to go, well, 68% is 0.68, and means multiply, but I'm actually going to change this number, because remember 0.35 is how many who purchased the warranty. I want to figure out who did not purchase a warranty, so that means 65% didn't purchase a warranty. So I'm going to multiply those together. get 0.442. Now I have to look at type 2. Well, type 2, let's put this right here, type 1. So type 2, 32% purchased type 2. Remember, I'm changing it into a decimal. And 56% did that warranty. So I don't want to know how many did buy the warranty. It did not. So if 56 did buy, then 44 didn't buy. Once again, I'll go do some math. That's 0.1408. So now what am I going to do with my two things? Because they were looking at type 1 and they were looking at type 2. So they have to look at type 1 or type 2. So 0.442 from type 1 plus 0.1408 means if I add those together, I get 8, 2 and 0 is 2, 4 and 4 is 8, 4 and 1 is 5. So that tells me that 58.28% of their customers didn't buy a warranty.